welcome to another NETGEAR webinar. I am your host, Sarah Moreno, and here to talk about protection strategies against the latest ransomware attacks using NETGEAR switching is Xavi, or Xavier, one of our NETGEAR product line managers. If you have any questions during the presentation, please use the chat room, and we'll try to get as many questions answered towards the end of the webinar. All right, take it away.
Okay, thank you, Sarah. Thank you. Welcome, everybody. My name is Xavi Deisa. I am the product line manager for switching here at NETGEAR, and I used to work as an SE also. So today, what we are going to cover is one of the most exciting parts of our networking is network security related to ransomware attacks. So as you know, guys, ransomwares are really quite popular. So what we want to discover in this webinar is how we can protect our networks and our computers using network security against the ransomware attack. So let's have a look first onto the agenda for today. So what we're going to see today is first is an introduction about the ransomware attacks, and a little bit is about what area and what angle we're going to see today about network protection. What we're going to see also is zero trust networks. So we're going to discover this new concept that is really important in terms of network security. It's zero trust networks, that it refers about how we can protect the network side and how we have to protect our networks in order to have like a really good solution in place. We're going to see that one. Network protection, we're going to talk about what are the layers of protection that we can add it into the network side to protect our systems against the ransomware attacks. And at the end, we're going to see like how we can protect also our backups using network protection. As you guys know, in the ransomware, we're going to see it, but one of the targets of the ransomware now is also to encrypt backups. So we also want to see like how the network can protect our backups. So we are going to talk about how we can build a network that protects our backups to be encrypted. And just to finish, we are going to do a question and answer session. So I hope you guys, you're going to enjoy it. And as we said, like any question that you get it, we are going to have a question and answer at the end. So feel free to ask any question about it. So first of all, how big is ransomware? That's something I know, guys, that is probably not much to talk about it, because most of you, you have some customers who already suffered from a ransomware attack. You have people who already got some encrypted computer due to the ransomware, and even like some people who already pay for these ransoms. So just to let you know, guys, we are gonna share and we're gonna send the presentation after we finish the session today. Okay, so you guys, you're gonna have a copy of this presentation and also a recorded link. So if you have to leave earlier, feel free to get it back with the link and see the recording. So getting to the ransomware solution, just getting how big they are, like how has changed the ransomware landscape in the last year. So the first ransomware, it's quite old, guys. It's 1989, so it has been like that for a long period of time, but it really picks up in the 2010 and after. So here we just have like the ransom demand variation over time. So what you guys you can see is that it's getting more and more crowded, and it's getting more and more expensive. Also, you see CryptoWall, CTV Locker 700, Toro Locker $500. So that's like how big they are and how expanding these kind of ransomware attacks are getting. So as you can see, guys, we have the biggest one is file encryption. That's really, really huge. But you guys, you can see that we also have Also other attacks like scareware or lockouts to lock up the computers, MBR encryptions, and now in the latest years we also see SMS lockout and mobile. So we can see ransomware also in mobile devices, and we also get Mac. So yeah, as you can see, guys, nobody is safe in this present in this world, in this ransomware world. So we have to make sure we protect the different kinds of devices and to get like this level of protection in a high level of time. And also one of the biggest issues with the ransomware is that normally we have been focused on security on the prevention area. So for ransomware, antivirus, and all these other technologies, unfortunately, it's not good enough. So that's why ransomware changed the world of network of the protection of the security, because in the past we rely on the antivirus and we rely on different techniques to get the protection. But here it's the first one that has to change this rule. And now we have to be also focused not only in the detection phase, because we know that we are going to get infected. Unfortunately, that's the reality. We don't have any tool that we can guarantee that we have that we are not going to get infected. So we need to put more layers of defense to make sure the expansion or the impact of the ransomware is limited. So how we can check this impact of the ransomware? So just like a quick overview, if somebody is not familiar with how it works, the ransomware, you get like one of the emails, you know, now it's, for example, peak season on the tax, ads and everything. So you're gonna see like information and ransomware related to tax and other stuff. So you just click the URL. When you click the URL, unfortunately, it's 0-day threats that they are using. So unfortunately, some of the antivirus will not catch up. You get the ransomware downloaded in your computer, and when it's downloaded to your computer, it will start encrypting files. So that's what is going to happen. And suddenly you're going to get a message like, hey, unfortunately, you get like your files are encrypted, and if you want the decryption key, you have to pay with Bitcoin. So that's how a normal ransomware it's working for a file encryption. But what we also want to make sure, and something that I want to highlight here, is that what they're going to try to encrypt is our computers. That was the first ransomware threats, but right now they are encrypting the network shares and the backup targets. So they are getting smarter. Not if you got like, you know, if you got like your computer that's encrypted, but you have the backup, not an issue. But if they encrypt also your backup, well, that's getting tougher to get the recovery. So they are always thinking ahead also. So, you know, like at the beginning when we were hit with ransomware, we know that the best way to protect is having backups. Still one of the best ways to protect, to get the backups ready, to get back to the normal status. But we also have to think about how we can limit this impact of this ransomware. So if we look like how a threat or a ransomware is hits our network, what we can see here is that first we get this link, we get the infection of our computer. But what we are going to talk today is about the network protection. So when we are infected our computer, the ransomware, as we saw, it's not only focused in our computer, it's going to try to encrypt the network shares. It's going to try to encrypt the backup targets. It's going to try to infect other computers. So what the network protection is going to help us is not in detecting the ransomware. It's not in this phase. It's not in the prevention phase. It's in the mitigating the impact of this ransomware. So how we can limit the impact of, for example, get the network shares encrypted. How we can limit that the other computers gonna get infected. So that's the network protection play in this ransomware, and that's the area that we're gonna talk together. So in order to implement this security in our system, we have to introduce a new concept that's called zero trust networks. So what is zero trust networks? So currently, that's really, I am sure that's going to be really familiar for a lot of people here. Currently, the presentation, currently most of the networks that we have, sorry guys, we are gonna have also all the different presentations here for you guys. Just to highlight it here, what we have in this scenario is a typical network in SMB in most of that we can see in many customers. So we have a computer. This computer is in the trusted network. So all the computers are in the trusted network. So when you are in this computer, as you are in your LAN network, you can access to all your different servers, even the web server, for example, the backup server, the management server. So once you are into the network, we have this flat network architecture where all the devices are trusted. So any computer can access to any other. So that's normally how it works, and that's normally what we implement and what we can see in many SMB environments. So here we have to think ahead, and we have to think in a new type of architecture. So what's this new type of architecture? It's called Zero Trust Network Architecture, and what it means is that we cannot trust anymore the users inside our organization. I know that this is tough. It's like they're already inside our organization, and we say that we cannot trust them. So that's what we are saying here. So what we are saying is that we also need to implement protection into the network side, not only in the perimeter, not only in the gateway. We also have to implement the protection into our network to limit these, for example, network attacks or that we can have due to the ransomware. So if we look like the ransomware process and the zero trust architecture, what we can see is that, we have different layers of protection that we can add into our network. So we can add cryptography, we can add activity monitoring, content filtering, access control, intrusion prevention, and firewall. And today, what I'm gonna leverage is what of these areas and features we can leverage using our switches. So let's talk about that. So about the network protection that we can offer in the zero trust environment. So first of all, for the zero trust networks, what we have seen again is different layers of protection that we can implement. We can implement network isolation, we can implement firewalls, we can implement access controls, activity monitoring, IPS, and crypto. So first, we are going to start talking about the network isolation. So how we can isolate the network. So how can I make sure that my computer, if one computer is infected, it's not going to infect the other computers in my network. So we have two different ways to do that. We have VLANs that we're going to cover it today, and we have something that's called protected ports that I'm going to show it to you guys how we can, what's the main features of these protected ports. We have firewall. So the switching area can be also firewall that's using ACLs. So we can use the switches as a switch firewall, as a network firewall. So we have this capability in our smart and our managed switches, and we can use it to implement a firewall inside our network. We have access control. That's other technologies that allows us to make sure that the device that's connected to our network is going to get identified and it's compliant with our security. So we are going to see a little bit of the 11.1x. So that will require an entire webinar, and hopefully we are going to do more webinars to explain all these different technologies and how technically they work. This first webinar is more to understand the problem, the challenge, and the benefits of implementing all this security to counterfeit the ransomware attacks. And the last one that we're going to see today in terms of the network protection, it's called the SNMP NMS 300, so activity and monitoring. That's also another important way to increase our network protection against ransomware using SNMP with our NMS 300 series. So first of all, what's the VLAN and how VLAN works? Why VLANs are really important to protect us against these ransomware attacks in this when they try to infect the other computers. So normally in a switch without VLANs, what it happens is that everybody is in the same broadcast domain. So if we look like a switch internally, we have like a zoom in the switch. What we are going to see is that we have this table here. We have the different ports, Ethernet 1, Ethernet 2, Ethernet 3, Ethernet 4, and we have the different MAC address of the different computers, MAC 1, MAC 2, MAC 3, MAC 4. If we don't have VLANs, everybody can see everybody. That's great, you know, plug and play, it works, no problem, easy to use. That's why the network, the switches and the network switching, it's really easy to implement normally. You just connect the switch, connect the devices, and it works perfect. But we are getting, in order to be able to do that, our security level is really, really low, because that means that, yeah, if the computer A is infected, it's easy for this computer to get to infect all the different computers. So the first way to do it is we have to try to segment, to isolate the network using VLAN. So at least, for example, if the ransomware affects the network, will only compromise, for example, one department or a few computers, not all of them. So the first thing is to implement this VLAN implementation to limit the network infection of this ransomware. So we can limit it, for example, in the file servers, backup servers, for example, for the guest access. So making sure that the guest will not infect our computers, or for example, bring your own devices that we are getting into our network. They are really isolated, so that they are out of our normal control policies, so they can get isolated into the network. And as you can see, like we have the stop signal here. So the most important thing is that the blue lines, for example, this computer and this computer, because we normally implement port-based VLANs, and that feature is available in our Plus and Smart and Managed switches. The devices that are in the same VLAN, they can talk to each other, but for example, the devices that are in the different VLANs, they cannot talk to different computers. So that is a way where we are gonna limit the impact of this ransomware attack. The other way is that we can talk and we can leverage about the VLANs. It's something that's called private VLAN. So a private VLAN is a VLAN inside a VLAN. So what does it mean is that we have an extra level of protection in terms of the VLAN. So as we have seen it here, in the past, in the normal VLAN implementation, everybody that's in the same VLAN can see each other. But in the private VLAN, we go to one step farther. What we have, for example, let's see here that we are using the CCTV implementation in this case. So what we have, for example, is cameras connected to the different network ports, and we have a server, a recording server for that one. So what is doing the private VLAN is that the cameras are in the same VLAN, but this VLAN has something that's called isolated ports. So the traffic goes from the camera, for example, that's connected in the port number 2 to the server. The traffic passes also between the camera and the server again, but no traffic, as you guys can see on the point, no traffic passes between 02 and 03. So between the cameras is no traffic. So that limits the possibility of the ransomware to get infected other computers. So thanks to this traffic limitation, we are gonna limit the impact of the ransomware attack. Another way to implement it, and that's really an easy way to implement it in the network isolation in our switches, is using something that's called protected ports. So that implementing private VLANs or implementing VLANs for every port. sometimes can be difficult because, if, for example, if you want to implement 1 billion for each port, it's gonna be like tough. But what we also leverage here is a feature that's called protected ports. So what it does, protected ports, the image here that we are showing, sorry for the quality of this image, it's not that great. But what we can see here, it's really self-explanatory, is that computer A and computer B with protected ports, they cannot talk to each other, but they can talk to the server. So that's another way that we can limit this exposure of getting other computers infected in our network. And the biggest benefit of the protected ports is how easy it is to implement. So we just have to go to security. Here we have the protected ports, and the way that it works is that we have here all the ports. As you can see, that's a 28 port suite. So the ports that we select here that are protected are the ones that we can talk to everybody. The ones that are not selected are isolated by default. So for example, if you just have one server and one router, you just have to click the server and router on the port, and automatically all the other ports gonna get isolated between them. So that's a really easy feature to implement. Later on, guys, thanks for typing all your questions. Feel free to add more questions there. Later on, we are going to go through all of them. So later on, Daniel, I will cover your question about the access point. So that's about the protected ports. The other thing that we can implement in terms of the network security is a network firewall. So what's the network firewall? So here, what we have in the switches, in the smart switches and in managed switches, we have what we call the network firewall. That's the ACLs, the access control list. So how it works is that, for example, you can see on the image below, we have the human resources network and we have the R&D network as example. And we have host A and host B. So for example, I can set up a rule where I say host A can see the human resources, but for example, host B cannot see human resources. For example, that in the ransomware way, we can limit which protocols, for example, we want to be able to, the different computers can see the server or the backup tool, so we can limit the way that we are seeing the different protocols. So the ACLs that we can implement in our switches are related to we have the ACLs, the ACL is related to the MAC and to the IP. So we can put rules based on MAC address. So looking to the presentation before, we can use the MAC address as a rule to secure our network, or we can use IP. So when we are using IP-based rules, we have two types of these firewall rules. We have the standard rules, that's the IP source base, so we only control the source, the IP source base, or the extended, where we have IP source, destination, port, so same as any firewall, where you put a basic firewall with IP rules, where we put IP source, IP destination, source port, source destination, so we can filter what we want in terms of traffic here. That's, for example, about our network security in terms of firewall. Another area that we want to leverage when we're talking about the zero trust networks is the network authentication, the .1x. Here, I only want to do like a highlight presentation about how it works, the .1x, because that, again, it's a huge topic. So what I want to highlight here is that we have a client. What we can see, that's the physical port. Imagine that's the switch. So we need now, what we recommend is that you have an external server, normally a Redis server, for authenticate this device. And what we are using here, the network authentication. Yeah. So for the network authentication here, what we can see is this .1x. So we have the client again, So the clients are getting connected to the network switch where we have these physical ports. So normally, you guys know, you go to the switch, you just connect to the device, to the network port, and automatically you get your network connectivity. You get your network connectivity done. So you just plug it and it works. You don't do any extra check in terms of security to make sure that this device is authenticated. So what we are leveraging here is same thing as a wireless, for example, authentication system, where what we have is before we access to the network, we have a username, a password. Normally in the network, in the wireless, we have a network key, but we can have a username and a password. So when we have this username and password, that goes to this server, the Radius server, and the Radius server sends back an authentication packet to say, hey, this username and password, they are correct. So this computer it's allowed to get into the network. And there is, for example, in the managed switches, we have extra features. For example, what we do there is we have dynamic VLAN assignation. So for example, depending on the user that you are typing, you get, for example, into the guest VLAN, or you get into the R&D VLAN, or you get into the human resources VLAN. And also, if you want to implement even more secure ways, you can run some software to check the compliance of the computers before you get authenticated to the network. So as I said, guys, that's only a global overview in terms of how the .1x works, but just to let you know, the best way to compare it, in my opinion, is about to get the comparison with the wireless, but in an enhanced way. So normally on the wireless, you guys know, we are using a password. In the network, we don't use a password. If we would like to do same sort of security, we should get like this .1x implemented. Just as I saw, like one of the questions, just to let you know, guys, PAE means port access entities, just like one of the terminologies that we are using in the .1x. So that's what it means, the .1x. So yeah, let's go ahead. Sorry guys, I will try to slow down a little bit. I was a little bit concerned about the time that we want to cover here. So as I said, you guys were also gonna see like the recorded view, but I expect that we are gonna be able to finish on time too. So sorry for that. Here, another way that we can improve the network security in our devices is the traffic monitoring. So how we can realize that, for example, if a ransomware is hitting our network. So I just put on this slide one example of like a ransomware hitting one of the network and one of the ports, the port that was connected to the network share. So as the ransomware tried to encrypt all the data of this, all the comments that they are sending and moving the packets. So what we can see is some peaks of traffic, but some abnormal patterns in our traffic. So the key here is to be able to monitor in advance, because what happens with the ransomware is that sometimes you don't see the ransomware till you get the message, but the ransomware, maybe sometimes, I remember one case in Australia, in this case, it was 1 year ago, like the ransomware hit the network like over the weekend, and it took 1 week for the guys to realize that the ransomware was running on the background, and it was in a school. So it was able to encrypt, I think that it was at that time almost 10 servers during 1 week, because the encryption process, it takes time. So the thing is that if we are able to to detect earlier that the ransomware is on our network, because we can see the different network patterns, we are going to be able to protect earlier our devices. So in order to get this detection, the best way to do it is to use the traffic monitoring. And in this case, what I will leverage is our solution is the NMS 300. It's free for the first 200 devices. You can install it in a Windows platform, and it's going to automatically discover your network switches, and it's going to create traffic. It's going to create these graphics that it tells you what is the traffic status in your network per port. So you can see like if there is any unexpected behavior, and also you can configure triggers, alarm triggers, to get, if, for example, if the traffic reach some kind of limit that's higher than what we expect, you can change the trigger, or you can customize this trigger to get you an email when, for example, the port number 5 in switch, in the data center switch, gonna get affected for the ransomware. That's or gonna get like, it has a peak rate. So you guys, you can check it and have this early detection. Let's move forward. So that was what I wanted to see for the network protection, but I have a couple more things to share here, guys. I would like to share also how we can protect the backups, because as you saw, like one of the biggest recommendations for the ransomware is, honestly, you guys need backups. You need to have the backups ready. And so, because as I said, like the biggest problem with the ransomware is that till today, no one can guarantee that they can detect and protect for us to all the ransomware. So the way that we want to protect also our network, it also has to be about the backup protection. So how we can protect our backups, that's the other way, using the network. So let me show you a couple of features that I would like to leverage here. So the first one is related to the VLANs. So the first one is quite easy, as we already covered it, is to implement a backup VLAN. So here, what we can see is that we have the network with different VLANs. We have the voice over IP VLAN, where we connect our phones. We have the sales VLAN. So we have these department VLAN, sales VLAN, guest VLAN. It's really important. That should be like a minimum features of our networks. We should have like a guest VLAN isolated from our corporate VLAN, the admin VLAN, and we have a backup VLAN. So we have a VLAN. As you guys know, most of the servers come with 2 network interfaces, 4 network interfaces. For example, already in Access, they come also with 2 interfaces in most of the cases, and we also have some of them with 4 interfaces. So we can do a VLAN segmentation based on a logical segmentation, just using one cable and running one VLAN per port, or we can do like, we can dedicate one of the ports to implement this VLAN here. And the other one that I want to share with you is something really interesting that we covered this one in a SANS presentation. So it's a PoE pass-through. So just gonna get introduced to this new technology for you guys. What is PoE pass-through exactly? The PoE pass-through is a way where we can, you're gonna see, let me just put here the light. So we can see here this switch. So this switch below here on the table, that is really, it's just connected to the electrical network. And the next switch, the switch that is on top, this switch is getting power from the switch on the bottom. So it doesn't have any connection to the electrical power. So here, what we want to leverage in the PoE pass-through is you have a switch that we know that what is PoE, so this, you can deliver power. But the new technology that PoE pass-through is switches that they are able to be powered by PoE. And some of them, they are also able to power other devices. So that's what it is, PoE pass-through. So it's, as you can see in the middle of the switch, this image below, the switch in the top, it's getting power from the switch on the bottom using these two Ethernet cables that you can see. And at the same time, it's able to power, for example, one camera. So that's what it does, the PoE pass-through. So how we can leverage this tool to a ransomware attack. So that's a little bit challenging, I know, but let me show it to you guys what we come after thinking about the best way to protect the network and protect these backup targets. So as you know, as we already defined, one of the main targets for the ransomware is to encrypt our backups. So that's what they try to do. And normally, as you guys know, we have like a backup. We're using Readiness. That would be like the best one as a backup target. I mean, like an SMB share or an NFS share. But they are already always on. So they are already published into the server. So what we can do here and what we can use as a backup targets on schedule, that's this feature that we come after. It's the sorry guys, but yeah, I can see I don't know if it's my connection, but the slides that you're gonna see are gonna be much better because I can see that, yeah, it's not a problem only on the presentation. Yeah, it's more an issue on the resolution of the Zoom. But the main thing here, what I want to leverage is that what we can do is look at the diagram on your right. We have the server connected to the first switch, and we have another switch. This is a pass-through switch that's connected to this main switch. So the big switch, the main switch, we can set up something that's called PoE timers. So we can set up a PoE timer where the PoE port gonna be delivering power, for example, from 5 a.m. to 7 a.m. And what does it mean is that automatically, as we have this pass-through switch here, this pass-through switch means that this switch is only gonna get power gonna be, this is only gonna be active when it gets power from the main switch. So that will give us connectivity, for example, to the network target only from 5 a.m. to 7 a.m. So what is the biggest benefit of doing that is that we can align, we can synchronize our backup window time. So when we do the backups, when the targets are available. So for example, if I know that the backups that I am doing, they normally run from 1 a.m. to 3 a.m., for example, I can make sure with this technology that the backup target will only appear from 1 a.m. to 3 a.m. So if a ransomware hits my network and try to encrypt the backups, they will not find it. If they only gonna find it if they are able to run the ransomware script from 1 a.m. to 3 a.m. So you can see here like the good benefit of using these PoE timers and this PoE pass-through to get an extra protection of your backup shares. So that's, for example, we implemented this one to a few customers back in Australia, and I can say that, yeah, the number of ransomware attacks when they were hitting the network, they weren't able to encrypt the backups anymore. So that was really, really efficient, this one. So, Yeah, we are gonna cover now. Just let me finish the last slide, and we are gonna start with the question and answer. So the summary, the wrap up. What is important, and get to the point. What is important to protect our network for the ransomware attack? So limit the attack surface using network isolation. So implement VLANs and protected ports as much as you can. That's for the network side. Second one, monitor your network traffic using the NMS 300. Build an isolated network backup with VLANs. Again, do this backup VLAN. And the fourth one, and the last one, implement backup targets on schedule using the pass-through switches. So that's my four advices, my 4 recommendations to get a better network protection against the ransomware attack. So now we are going to do the question and answer. I know that Derek is on the line. Derek already answered some of the questions of our team here. So Derek is our SE in North America. He's a really experienced network engineer and good guy. So sorry guys, but I was just reading the question. So yeah, let's go through the different questions that I think that we haven't answered. And if any of those, if I miss any question, please guys, just let me know. So Andreas were asking us if we have the presentation from January and February. Yeah, we're gonna email to Andreas the presentation, but if you can email us also in the uspowership@netgear.com, you are gonna get all of these presentations. There is another question about from Danielle that is, how does protection port affect access points? Will they still work? I think that we already covered this question with Derek, but yeah, they add an extra level of protection in the access points, Daniel. So we also have the wireless isolation. So wireless isolation, it has to work together with the network isolation. So the wireless isolation works in another level. The best way to do it, in my opinion, is to have a wireless VLAN segmented, isolated already itself. So you have wireless VLAN plus this wireless isolation to get the same kind of isolation that we want for the network. And Tim was asking us, does this work with smart switches or just high-level switches? Most of the features that we saw are related to smart switches, so they are almost all are applied. You can use it in smart switches. The only thing and the only consideration is that you have to balance your workload, because if you are adding many features into the smart switches, the hardware, the processor and memory, it's more limited than in managed. So all of these features are available in the smart, but we recommend, for example, if you want specifically to implement, for example, ACLs or other ACLs specifically and the .1x, that you get like probably a managed switch to get like the workload balance. And Tony is asking us, can we have a list of switches where the PoE power can be put on a timer? Yeah, we have a PoE poster that we are gonna send it to you guys, where you're gonna be able to identify what are the switches that are PoE passed through. So currently we have 4 of them. We have one that's the GS108T. That's an 8-port gigabit switch with 1-port PD. So what it means is that this switch can be powered from a PoE, but cannot deliver power. Okay, so that's the basic one. We also have the GS105PE. That's a small switch, 5-port with the pass-through capabilities. So we have 5-port with pass-through. We have 8-port with pass-through. We have 12-port with pass-through. So and 16-port with pass-through. So we have 4 switches that has this PV capability. So when you look in a switch, just to let you know, guys, I will recommend that you check if the switch has PD. PD means powered device. So if it has a PD port, it means that this switch can be powered by Ethernet. So that's what it means, the PD on the switches.